Oh, our lesson on rewriting equations. The directions in the first section say find the value of y for the given value of x by first substituting in x and then solving for y. So this is one method. They're going to give you an expression or an equation, and they're going to tell you x equals 3. So generally, this is how an Algebra 1 student would do this problem. They would go ahead and substitute in the x. So this is really 6 plus 3y equals 12. And then they would go ahead and solve for y that way. So they would subtract the 6. So they do all their algebraic moves at the end of the problem. And then when they divide by 3 on both sides, they end up with y equals 2. And that's a fine way to do that question. There's nothing wrong with that. So same idea here. We have an algebraic equation, and they provide us a value for x. So we're going to substitute that value of x in at the beginning per the instructions. Let's see, that's 4 plus 5 is 9, equals 3 minus 2y. To solve for y, most of you would subtract the 3 over. So 6 is negative 2y. And then final step, when you divide everybody by negative 2, you end up with a value for y of negative 3. We're going to skip number 3 because I'm bored already. So that is one technique. Substitute in the value for x first and then solve for y. Now, could you imagine if I gave you that one question and I had you substitute in like 5 different values for y? Well, if you did this method, you would be solving for that problem 5 times. It would get really tedious. So in that case, we will want to use another technique. So keep skipping ahead in your notes all the way down to number 7. And the directions change. It says instead of substituting in the x first, they would like you to first isolate the y and then substitute in the x value. So when I look at number 7, they want me to first isolate the y. I always tell my kids to put a box around the variable you're trying to isolate and pretend it's glued down. It's not going to go anywhere. But we're going to peel every other term off of the y or away from the y. So back in Algebra 2, you learned your first step to isolating the y would be to subtract this term over. It's an addition problem technically right now. So the 3x is gone, and on the left-hand side I still have 2y. Over here on the right-hand side though, those are not like terms, so algebraically I see 1 minus 3x. You could also write that as negative 3x plus 1, but because of our goal today, I'm just going to keep it simple and write it as 1 minus 3x. Last step to solve for y, remember trying to solve for y, is we're going to undo the multiply by 2 by dividing by 2. And it's okay for Math 4, because we're going to be doing some big kid stuff, if you just leave it kind of messy. Big fraction bar, divide by 2. So my formula for y is 1 minus 3x, and then divide that difference by 2. So now we're going to go back and say, okay, what if x equals 5? So instead of 1 minus 3x, it's 1 minus 3 times 5. Now if you're doing this on your calculator in one step, make sure you put the numerator, because it's more than one term, in parentheses. If you're using your old noggin, that's just 1 minus 15, which is negative 14 divided by 2. So negative 14 divided by 2 is negative 7. Some kids are looking at that going, well, that was not easier. For one go of a problem, it probably was not easier. But what if now I said, like, hey, I want you to go plug in these 10 values. It'd be a lot easier to program your calculator to use your table or some sort of a storing function rather than having to solve for y 10 individual times. Let's continue on with number 8. So again, same method, we're going to solve for y. This one's a lot easier to isolate. Right now it's being subtracted by 2x, so I'm going to add the 2x to the other side. Y'all probably got really good at this in Algebra 2. Either order, 2x plus 12 or 12 plus 2x, it's the same equation. Now I'm going to substitute in the value for x equals 3. So y is really 2 times 3 plus 12, so that's 6 plus 12, so y is really an 18. And then the next question, still same process, I want to solve for y. So right now it's being added to the 1/2 x. I'm going to subtract the 1/2 x over to the other side. So we're going to end up with 1 minus 1/2 x. If you wrote negative 1/2 x plus 1, that's the same thing. But we're not done, because now they want me to take a value for negative 6 and substitute it in for my x. So y is really, let's see here, negative, well, 1/2 times -6 is -3, but we have a double negative situation happening here. So you really have a 1 plus 3. So our y value is actually a 4. Of course, you guys are welcome to use your calculator as opposed to doing any ounce of mental math. You know I'm okay with that. Let's see what's coming up. All right, let's look at number 10. Same process. They want you to solve for y first, and then they want you to substitute in the x. So we got a few things happening here. I'm going to have to move the 4 over and the -2x over, which means I'm going to add the 2x, and I'm going to subtract the 4. It's kind of a mess right now. I know some of you from Algebra 2, you got to the point where you didn't have to show like the add and subtract stuff. You just moved it and knew. That's fine. If you're there, keep going. So right now I have a 1/3 times y equals 2x minus 4. And I need to undo a coefficient multiplication of 1/3. So the easiest way to do that is to multiply by the reciprocal. So the reciprocal of a 1/3 is a 3. The trick here, though, guys, everything has to be multiplied by a 3. Everything. So 1/3 and 3 cancel, and you get y equals, and go ahead and distribute the 3. It'll make your math easier in a minute. It'll be a 6x minus 12. So now I have a prettier formula that I can evaluate for y quickly. So x is 2. Oh, well, that's cute. 12 minus 12 is 0. Now, number 11 were the more complicated questions for isolation. Oh, no, they aren't. Ignore me. We're not there yet. Let's do 11. There's only one y in the problem to isolate. It's not too bad. I'm going to add the 3x. So it's really 3x minus 4. If you wrote -4 plus 3x, that's the same thing. But my goal is still the same. I want to isolate the y. So I'm going to divide by x. And I'm going to cheat. I'm just going to do a big fraction bar like this. So the formula for y is 3x minus 4. And then I'm going to divide that subtraction problem by x. So when I go to evaluate at x equals 2, make sure if you're using your calculator, you have parentheses over around your numerator, because it's got more than one term happening. If you're using your brain, that's a 6 minus 4, which is 2. 2 divided by 2 is 1. Okay, number 12, we're isolating for y still. Right now I notice that the y is being multiplied by something. So I know the opposite of multiplying by a number is to divide. The weird thing about this problem is the thing that's being multiplied by y is an expression, x plus 3, but the math is the same. You're just simply going to divide by x plus 3 on both sides. So x plus 3's are gone on the left, and you have y equals this lovely fraction, 5 over x plus 3. Now when I go to evaluate that, that equation for x equals 7, that becomes, make sure you're using parentheses if you're on your calculator, that's really 5 divided by 10, better known as 1/2. If you wrote 0.5, you're not wrong, you know I like fractions better. All right, let's find something more complicated. Well, okay. I'm going to do 13 and possibly 14 with y'all. They're not meant to be complicated. I just want to make sure you guys understand how not complicated they're supposed to be. So these are real-life formulas that we use often in math applications. The first one's the distance formula, which we worked with previously in those chart problems. Distance equals rate times time, and I want you to isolate for the time. Well, time is currently being multiplied by rate, so to undo that, I would simply divide by rate. And math law says if you do it to the right, you got to do it to the left. So these cancel, and right now I'm just going to write down what I have. Distance divided by rate is time. If it bothers you that the t is on the right instead of the left, just pick up your equation and flip it around. So I would do like a happy dance if I had that on a quiz. That's a good quiz. So I'm going to skip ahead to 15. And this is the interest formula, principal times rate times time. Again, it's still a multiplication problem. The only thing that complicates this question is if I'm trying to solve for rate, he's got 2 multiplications attached to him. Well, because it's the same operation, you can actually do it in one step. I know I have to divide by p and t, so I'm just going to do it in one step. Divide by pt on both sides. So on the right-hand side, you're just left with r. And on the left-hand side, Interest divided by PT. Let's look at 17. Overkill, what'd I tell you? Too many problems. We got to skip around. All right, height equals the square root of 3 over 2 times s. That happens to be the formula for calculating the height of an equilateral triangle. Fascinating. Let's solve for the length of the side. Now, we talked a few problems ago about getting rid of a fraction coefficient. We're going to multiply by the reciprocal. So the reciprocal of square root of 3 over 2 is 2 over the square root of 3. We just got to make sure we multiply it to both sides. So on the right-hand side, those cancel each other out, and you just have s. And on the left-hand side, you have 2h divided by the square root of 3. Now, some of you remember from your previous work with radicals, it's not mathematically proper to keep a radical in the denominator if you were like providing a final answer to something. I think for our purposes, we're just going to leave it, though. So leave it. Because if I was using the formula, I wouldn't care. I would just crank it in the calculator. So, yeah. All right, moving along. 21. So this is the formula to calculate a Fahrenheit temperature when you were given Celsius. But what if I have the reverse of that? What if I'm given Celsius and I need to calculate for Fahrenheit? Like you go take a trip to Canada. Catch that joke? That was a good one. That was a catered Canadian joke for you. All right, so let's solve for C. First off, I noticed the plus 32. I have to move that over first by subtracting 32 to the other side. So let's subtract 32. So the Fahrenheit temperature minus 32 still equals 9/5 times the Celsius temperature. I still want you to solve for Celsius. So when I have a fraction coefficient, quickest way to get rid of it is to multiply by his reciprocal. But we had a problem a little while ago where I warned you that if you multiply by the reciprocal, that's great. Just make sure you multiply everybody by the reciprocal. And I'm going to be superbly lazy right now. And I'm going to leave my formula exactly how I see it. 5/9 times f minus 32 equals Celsius. Okay. You could distribute the 5/9. In that case, you're going to end up with either a decimal or a really funky fraction on the back end of that. So I think we're just going to leave it. Okay, let's look at 22. Area of a trapezoid formula. You normally see it as 1/2 times base 1 plus base 2 times height, but someone kind of simplified that formula and put the 1/2 and the height together and made it h over 2. I want you to solve for h. Now there are two things happening to h that I notice. H is being divided by 2. H is also being multiplied by b1 plus b2. So since those are two different operations, I have to kind of take care of them one at a time. I'm going to start with the divide by 2. To get rid of a divide by 2, I'm supposed to multiply by 2. Now that's one number. So if I multiply that by 2, these are going to cancel. But remember, you got to do it to the other side as well. So right now I have 2 area equals h times b1 plus b2, still in parentheses. Okay, I still want to solve for h. Right now h is being multiplied by something, so to undo a multiply, I'm going to divide by that something. So I'm going to divide by the b1 plus b2. Just make sure you do it to both sides. So those are gone. And I think I'm done. The height is twice the area divided by the sum of the bases. Woo! Same formula, different goal. This time they want you to solve for base 1. So two things are happening to base 1. He's got an addition problem, but this addition problem is kind of trapped inside of a multiplication problem. So it's like unwrapping a present. You got to start on the outside and work your way in. I'm going to start with the fact that he's being multiplied by a really weird fraction, h over 2. To get rid of my fraction coefficient, I could just simply multiply by 2 over h, the reciprocal. Just make sure you do it to both sides. So the h over 2 and 2 over h on the right-hand side will cancel, leaving you with 2a over h on the left equals b1 plus b2. Notice I got rid of my parentheses because there's no longer a multiplication happening, so I don't need them.